Hi, I'm Bob from Plastic Pipe Shop, and in this video we're going to have a look at the different types of non-return valves, sometimes called check valves, which will hopefully help you select the right one. Now, a non-return valve is designed to only allow water to flow one way along a pipe and prevent it flowing back again when the water flow stops. They can work in one of two ways. They either have a spring which assists the closing of the seal, or a non-sprung, and so opened and closed purely by water pressure and gravity alone. They work in a number of ways. They might use a flap like this wafer type here, which is designed to go between flanges and can come either with or without a spring. It allows the water to flow through as the force of the flow lifts up the valve, and then when the flow stops, the water pushes back against it, sealing against a rubber seal that, if we zoom in closely here, we can see here on the flap. There are also flap types like this one, which can be cemented on like a fitting. You can see if we zoom in here that if I give it a poke inside, the flap moves up and down, opening and closing. Just a quick note here on cementing non-return valves like this one. You need to make sure you can get access to the inside of the valve, as it may need maintenance from time to time to clear any stuff that's become caught on the flap and stopping it from closing completely. If the valve you choose hasn't already got unions either side like this one, then I'd recommend adding them so you can split the pipe apart. In place of the flap, others like this double union check valve might use a ball or cone which lifts away from the seal. But all work on the principle of a seal being released by water flow and then closing on it again when the flow stops. I'll show you this one taken apart, which gives you a better understanding of how it works. With the water flowing this way, you can see we have the rubber seal here, which sits against the face of the valve end. Then pushing and sealing against that, and aided by a spring, is a cone shape. The position of a valve in the system is very important. Valves which have a spring assist like this one we just looked at can be mounted in any flow direction, up, down, horizontal, or anything in between. But those without a spring should only be mounted with the flow going upwards through them, horizontal, or it's okay to mount at an angle as long as the flow is going upwards and not downwards. So why would you choose a valve without a spring? At first glance, you think that surely a non-return valve aided by a spring is going to be better. Well, firstly, on the suction side of a system, you should only ever use non-sprung types, as a pump will really struggle to lift against a spring. Due to gravity and atmospheric pressure, even the most efficient pumps have a limitation on suction of about 7 or 8 meters, or 0.7 to 0.8 bar. The extra suction required to lift against a spring is simply too much for most pumps. The valve ideally goes right at the end of a suction pipe. Mounting it further up relies on a vacuum seal, preventing the water from flowing back down. If it's not at the bottom, any air getting into the pipe from either the bottom or anywhere else for that matter will break the vacuum and the pipe will empty. In much the same way that as kids, most of us have pushed a straw into a drink, put our thumb over the end, lifted it out, and then watched the liquid inside fall out when we release our thumb and break the vacuum. Another reason for using a valve without a spring is that pushing the seal against the spring creates additional friction or head loss, which will lower the pressure and flow rate from your pump. This may only be by a small percentage, but if your pump's a low head one, it could be significant. This non-sprung flap opens and closes at a slight tap, but in contrast, the sprung valve needs quite a bit of force and so will create greater head loss. Whilst we're on the subject of head loss, the more convoluted a path that the fluid has to take through the valve, the higher the head loss. So types like this, where the fluid has to navigate round and past the cone and then is further interrupted as it flows past and through the spring, will have a much higher head loss than a simple open flap. Now, look at this. This is a 6-inch wafer type valve, but the hole is way smaller than the bore of a 6-inch pipe. Look at the wafer valve and 6-inch stub for comparison. It needs to be like this so that the flap can open inside the pipe. If it was bigger, the flap would jam against the pipe's internal wall. If we measure this, it's about 100 millimetres, so that's the equivalent of a 4-inch pipe. Pushing the fluid that's going through your 6-inch pipe through a 4-inch hole is going to add a lot of head loss and reduce your flow rates. In contrast, Flow Control, who make this type, have widened the body of the valve so that the flap opens full whilst maintaining an almost full bore flow, and so limits the head loss. Remember that as well as affecting your flow and pressure, any increase in friction and head loss also mean higher energy requirements to get the flow rate and pressure you need at the end of your pipe. Thanks for watching. Bye.